All right, we're going to do a little component. We're going to do a little component inspection here now, and along with the component inspection, I'll give you an idea how things work. Right. So follow my guide here. Let's start with the rear shock. Shock absorber on a bike. Here's a couple examples of aftermarket shocks. There's a Penske Racing shock and a Fox shock. The style here, this is called remote reservoir. This is the reservoir of the shock, the body of the shock, shaft of the shock, and this is typically the ride height adjuster mechanism at the bottom of it, okay? And I'll show you the damping adjusters as well here in a second. Piggyback is a fixtured reservoir on the shock, name pretty much describes it, okay? Pros and cons of each of these, I'll show you on paper. People like these because they're clean and simple and easy to install. And they're very, very crash proof. If you have to mount a reservoir to the subframe, it can be pulled loose from the shock when the bike crashes. But one drawback to these, the larger the reservoir, the bigger volume of nitrogen you can have, the better the shock will perform more consistently. And I'll make a drawing as to that in a minute. So if you end up with a small volume of nitrogen, the shock will perform less consistently. So this isn't necessarily better. And I'll demonstrate why here in a second. When you look at your shock, we do a component inspection. The primary thing you need to be concerned with is oil on the shock. The shock is leaking, okay? Now, I strongly encourage you, while you're at the track, every time you come home, be wiping your bike down after you ride it. Take a look at it, particularly when you get home, clean it thoroughly. By getting yourself in the routine of cleaning your bike as soon as you come home the next day, not the day before you're leaving for the track, right? Gives you a chance to touch every part of your bike and find loose bolts, cracks, things falling apart, things leaking, things you'll need to repair before you reel your bike off of the trailer and you're ready to go out for morning practice and find, there's a crack in your exhaust bracket or your shock is leaking, okay? So, should you find oil on your shock, the next thing you need to do is make sure it's coming from your shock, okay? Now, when we are looking at this shock, pretend it's coated with oil. What you need to do is look forward on the bike, make sure there's no leaks coming from the motorcycle itself. The oil pan, shift shaft seal, counter shaft seal, clutch cover, anything like that. Even a brand new chain will sling lube off all over the counter shaft sprocket area. That'll get hot, it'll leak down, blow back onto your shock. You may think your shock is leaking. So try and find the source of the leak, right? If your shock truly is leaking, it'll need to be repaired, professionally repaired, right? It's not a big deal. It should cost you $100 or less to have a new seal and have the oil changed in the shock, right? Second thing on shock component inspection is make sure that this reservoir is not scratched, torn up, dented, or dinged in any way, because there's a floating piston here, which I'll draw out in a second. And if there's any dents or dings, it can impair the action of the shock. So this thing needs to be rubber mounted to your subframe rail and securely, not with zip ties. And we need to make sure it's not dented and scratched up. People mount these with zip ties. Don't ask me why. Zip ties will break. This falls down on the chain. It gets bandsawed into pieces. Oil flies on your tire. Then your bike crashes. Believe it or not, this happens all the time because people won't mount this properly. So I see this probably 2-3 times a year where people do that. So secure mounting on this and make sure that it's not rubbing and scratching on the frame rail, rubber mounted in between, all right? All right, we're going to make a drawing of a basic shock absorber and show you how it functions real quick here. Here's the shock body, shock shaft. We have a piston inside the shock, some sort of mounting mechanism we'll call a clevis, some sort of top eyelet, the hose, we have the reservoir, an adjuster, and we're going to have what we call an IFP, or an internal floating piston, right? Now, shock absorber, down here we'll have two things. A threaded adjuster that we'll call a ride height adjuster. And what this does is make the shock actually make it so we can adjust its eye-to-eye length, center to center length, and make it longer or shorter. Race car guys are used to calling ride height adding more or less spring preload because they're cranking on the spring, the car's moving up and down. Now that is possible to a certain extent on a motorcycle, but that's not what we're trying to do because you're changing the spring preload, remember, in some instances, we just want to change the ride height, and we want to leave the spring preload the way we set it, okay? So down here on the bottom also will be your rebound damping adjuster. It'll be a knob, sometimes a screw on a lot of stock shocks. On both these example shocks, this knob here, rebound, all right? Compression adjuster. Any knob on the reservoir will be your compression adjuster. So this will be rebound. This will be your compression adjuster. All right. Now, this shock is filled full of oil and bled so that there's no air in it. Can't have any air in it. Now, microscopically, there is air in it, but your builder tries to get as much of the air out as possible. And whatever we can do to get it out, that's what we try and do. All right. Now, in this side, we have nitrogen gas. All right. Much in the way of with a tire, does it need to be nitrogen gas? Doesn't need to be nitrogen gas. It just needs to be dry air. We're just trying not to have moisture in it. And typically nitrogen is in a higher compressed state than you'll find coming out of your compressor, and we need higher gas pressures typically in shocks. They'll range anywhere from, some companies have them as low as 125 up to 300 depending on the application, PSI of gas pressure. All right. Now, so what happens is, as your shock compresses, fluid's displaced from this main body of the shock and it heads over towards this reservoir, and it's metered here at that adjuster, all right? And this floating piston will move down by the amount of oil that's displaced by this shaft, right? However much area a shaft enters, that's how much moves. Just like a bathtub full of water, you get in it, water spills out, that's what we're doing here, right? Now, this gas pressure pushes back. So when the shock wants to go and extend, it keeps all this under pressure, so no air, no cavitation, no vacuum happens, right? Pushes it back into place, right? And that piston will move right back to where it started from. Now, if you remember, I was talking about why a larger volume of nitrogen is better. The reason is, as this shock heats up and gets hot, everything in the world gets bigger as it gets hot. This pressure may rise. If we start at 150 and we get the shock hot, it may get to 155, right? Now, the second thing that's happening is the oil's getting bigger inside the shock. It's just getting hotter. It's taking up more space. So as the shock gets hotter and hotter and hotter, the oil just gets bigger, and the only place it has to go is into this reservoir, and it starts pushing this piston down slightly. So the static gas pressure on a shock will be higher when it's hot. It might be 165. This is actually enough to change your sag on your bike. That pneumatic spring pressure there will push up on your free sag, right? Now, so what we're dealing with is a percentage change here from cold to hot. If we have a little tiny volume of air, shoot, that might get up to 175. And that's a noteworthy difference to the performance of the shock. If we had a volume of nitrogen the size of this room, it might go to 150.1. So what we're trying to do is have that thing change as little as possible, and that's what a bigger volume of nitrogen does. So piggyback shocks are cool, but typically they have to deal more with this syndrome here, and so I don't, if you wanted the ultimate in performance, piggyback isn't necessarily it. So most people aren't tuned into that because, the factory guys run piggyback shocks, and so that's what people look for, right? Now, so if we want to make this shock feel stiffer, we're going to turn up the compression damping, right? Some of them have numbers, 1, 2, 3, 4, 5, 6, 7, 8 around there, and a dot on the shock body to align it to. You'll just roll the knob. On Fox and Penske here, the knobs rotate infinitely. You can't tighten it or loosen it, and what you're doing internally is just lining up a hole. You're lining up a little tiny hole, or you're lining up a bigger hole for oil to go through, right? Very, very simple in design, right? Now, anybody here have a Penske triple adjustable shock? Got one guy here with one. Now that shock has 2 adjusters on it. It actually has high and low speed compression damping. Remember we talked about this earlier, 2 types of damping. There's a little knob nested inside. The little knob is low speed damping. The big knob is high speed damping. Now, In the world of rebound damping, the only thing pushing back on this damping unit is the spring, okay? So it's very, very predictable. We can see whatever it's going to do pretty much anywhere in the world while we've got it in a static environment, okay? But bumps are a different thing. We can't push on a bike or simulate a bump under any circumstance. We can only simulate, get our low speed feel. You know, we can feel what the damper will do, right? Now, so rebound damping, not so critical to have access to tune high speed and low speed damping, all right? We can pre-program that because we know what the spring is on there and we know how it's going to work, no big deal. But the track condition's different for bumps. You may be at a smooth track, you may be at a bumpy track, right? Now why this is important is if we have an ordinary shock, like say an ordinary Penske or an ordinary Fox with just compression damping adjustment, this is a high-speed adjuster, and all we're really able to do is make the whole thing stiffer under all conditions or all the way softer under all conditions, okay? So the advantage to this shock is we can make it feel firm with low-speed damping, and yet we can tune independently for bumps. Now to translate into that into a track situation, if we took a normal double adjustable shock to a racetrack and we rode it around a smooth track and the bike felt soft, we would crank that knob up until it felt nice and firm to us, and we'd ride around, we were happy that day, and then we left and now we went to bumpy track X the next weekend. Well, now the shock is jarring you in the butt, you have poor grip and poor traction, you don't like, not giving you any confidence. So now what you have to do is soften that knob so you get the bike to soak the bumps. Well, when you soften the knob, it'll now soak bumps, but the bike will lose feel, right? It'll become soft and mushy again. So with this style of shock, we're able to independently tune those two variables. You'll find most top pro riders use this shock. Is this life and death important to you that you have that shock? No, it's not. You may find that as you if you get involved with tuning your bike and you really like tuning your bike, you'll get a lot of enjoyment out of this because you're able to fine-tune your bike in ways other people can't. If you leave here and just want to talk to your suspension tuner and don't want anybody to tell you, don't want to fool with it yourself, this is all you're going to need, right? And for the most part, people can fly around a racetrack on just a simple shock like this. But this is the maximum level. This is what you can get. And current time shocks like this are about $1,150. Fox and Penske shocks about $750, somewhere around there for a double adjustable shock. And those are some of the similar Ohlins, somewhere in between those two kinds of shocks, currently, to give you an idea what you might spend in money. So when you hear it talk about valving, right? Stacked on the main piston inside the shock are thin spring washers we call shims, valving shims or valving washers, depending on what company, what person you talk to. Basically, these act like one-way check valves, and they're the equivalent of a spring. So we'll have a piston, and then there's a series of shims. Now what a tuner does is he determines how thick those shims need to be, and what diameter they need to be, and in what sequence they need to be stacked, okay? Everybody's heard of having your suspension revalved. Having your suspension revalved is completely analogous to having your carburetors rejetted. Now, as of the taping of this video, carburetors are nearly a thing of the past, ancient history, and everybody gets to deal with fuel injection for the most part nowadays, but most people are familiar with carburetors and what they do. So when you take your bike into the bike shop and you have a jet kit installed and Mr. Tuner guy puts the bike on the dyno and he works on it and tweaks on it, what he's trying to do is tune a horsepower curve, right? So he's changing jets, changing needles, he's changing the position of them, and what he's trying to do is get you a curve, get you a horsepower curve that's big and fat, and when you came in you had less, and when you left you had more, and you're happy, right? Well, suspension tuners are doing the exact same thing. We're going in and you came with X and we're trying to get you to leave with Y, right? Something more or better, right? The only primary difference between what suspension tuners are trying to do and what engine tuners are trying to do, for the most part, more horsepower is better than less. That's we'll go after. In the world of suspension, more is not always better. We go for less in certain places. And what we're doing is in areas of the damping curve, we're looking for different things. When you see a damping graph, the top half will represent compression, and the bottom will represent rebound. And as long as we're in America, this will hold true. If you go other places in the world, It's upside down. Don't ask me how or why. So first time I went to Japan and somebody showed me a shock dyno graph, I thought the shock was broken. And until they explained to me that the thing was inverted, and I was shocked to say the least. So need to know what you're looking at, but in America this is all you're going to see. Now you'll see a graph represented as an average for the most part. If we were to actually take a shock and put it on a shock dynamometer, which is a machine that cycles a shock and measures the pressure it puts out, the data that's actually being collected is an acceleration in compression and a deceleration, and that's just one upward stroke because it was still, it began moving, and then it stopped. And that's what that represents. Same thing in rebound. When it comes back, you'll get this. What the line you'll get when you get something from a tuner is the average of those. Real tuners will look at the whole graph, but for the most part, so the consumer can understand what they're looking at, this simple design, this simple graph that's the average of all that is easiest to look at, right?